Hello everyone, welcome to my class, Fundamental of Engineering. Today we will discuss Chapter 3, Part 1. This one is Electrical and Electronic Engineering Fundamentals, but our today lecture is the Introduction of Electrical and Electrical Engineering Fundamentals. So what we are going to discuss today or the objectives of this lesson. At the end of the lesson, you can familiar with the basic definition, parameters and components of electricity and electronics. Okay. All the electrical or electronic materials fall into three classes. We will be discussing that too. Then about AC and DC current, basic laws, that is Ohm's law, Watt's law, okay, or the law for power. And then in terms of Ohm's law, the relation between current, voltage, and resistance. So let's see first. What is the difference between electrical and electronics? A very basic one, but we need to know before starting. Okay. Electrical is refers to or it deals with high AC current, voltage, energy, etc. And it also referred to their generation and distribution, can be for short distance or for long distance. Whereas electronics, it deals with science and technology to develop electronic devices or machine, okay, like IC circuits. This is the main focus of electronics. It uses DC current with low voltage, energy, and design of devices for everyday use or implementation of our daily life. Okay. For example, all the household electronic devices, okay, such as our mobile phone, TV, radio, oven, microwave oven, all are electronics devices. Whereas you can see very clearly, electrical refers to huge devices of electrical current, okay, generation of voltage sources and distribution. So we can see from here the difference between electrical and electronics. They seem similar, but they are quite different. Next, the terms and units, okay, for electricity. Now, it can be broken into the components like electrical charge, okay, voltage, current, and resistance. Okay, so these four actually the basic units of electricity terms or electrical terms. And then here you can see their symbols and unit, like charge is denoted by Q and its unit is Coulomb. Voltage is V, is volt, its unit is volt. Current is I and its unit is ampere. While whereas the resistance symbol is R, unit is Ohm. It's a Greek letter. Next, all our electrical or electronics components or generation or means our use, it depends on electricity. So we need to see what is the mother or the base of this electricity or electrical current. Okay, so it depends on the electron theory, and it's come from very tiny materials, which is known as is a part of the materials which is known as atoms. All the materials in this universe are made of atoms. So what are there inside an atom? There are two portions, mainly nucleus, which is combination of protons and neutrons. Proton is positive charge, while neutron is neutral. There is no charge. And the other one, which is the focus of our electric engineering, is the electrons. Okay, the electrons are very tiny component inside the atom and very light, which is negatively charged, and it circles the nucleus following a orbit. Okay. So that's why these electrons can flow or move from atom if there is a force. Okay. Okay. And the force is enough to replace the electron. Electron is negative, and same amount of positive charge. Proton is in the nucleus, so all the atoms are basically neutral. So this is the base of our electric or electronic engineering. Okay, so let us see the electrons. The smallest amount of electrical charge. Okay, negative, and we can see is orbit the center of the atoms, and we can see here is an atom of copper. Okay, so there are 29 protons in the nucleus and 29 electrons orbiting around the nucleus. Okay, so what we can see, there is only one electron in the outer orbit. This is the main cause of copper is a very good conductor to conduct electricity, because with a little force, this electron can move out and flow around. Okay. So that's the flow of charge and electricity. So this is a good conductor. Proton. Now, usually in a atomic orbits, if there are 8 electrons, then it is quite enough to be neutral, and no electron can go out or can come in, can flow, something like that. So they are stable, means they can be insulator. There cannot be any movement of electron. But if the outer shell, which is very far from the nucleus, so attraction is less, and if there is less than 4, okay, they are intend to move out. And in case of copper, there is only 1, so very high possibility to move out and conduct a flow of electron or current. Okay, so this how the current flow. Okay, the flow of electrons in a conductor. So free electrons, the very low force, it can go off or go out and then flow from one atom to another atom through the copper conductor. So all are here, we have to keep in mind all the electrons are negatively charged, and flow of electron always from negative to positive. Why? Because electron is negative, so its intend always to go to positive, attracted by positive charge. So flow is from negative to positive. Now, depending on the atomic structure and electron arrangement in orbit, all materials are classified into 3 classes. And all materials can be one of the 3. Okay, what are those? Conductors, insulators, semiconductors. As we mentioned, who are conductors? Let's see. So conductors have only one valency electron in the outer orbit, just like copper we have seen. Okay, so materials in which electrons can move freely from atom to atom are called conductors because only one electron and they are very intent to go out and move out. So examples, materials, usually materials, but they are 4 very good conductors. They are number 1, silver, gold, copper, and aluminum. But silver is most widely used. Gold is very expensive. Next, copper. So copper is less expensive and good conductor. So most widely used. Why is aluminum is good, but it's risky, bit risky to use it all the times. Okay. So use of the conductors to conduct electricity. Okay, with minimum resistance. Here to mention, good conductors have very less resistivity. Means they can follow electrons very easily, don't resist the flow of the electron. Now let us see insulator, opposite of conductor. Okay. Insulator have 8 valence electron in the outer orbit. So they are stable. They don't want to mix with any other. They don't give out the electrons or receive electrons from other atoms. That's why materials in which electrons tend to stay put and do not flow easily from atom to atom are known as insulators. Okay. Insulators have very high resistivity rather than conductor less resistivity and prevent flow of electricity. Means since resistivity is very high, they intend to resist the flow of electron. Example, insulating materials are rubber, plastic, wool, glass, all are insulating materials. And what is their use? They use as dielectric materials in capacitor or to insulate the conductor. What we can see, all the cables, okay, conducting cables inside copper or silver, but they are insulated by a cover. That cover is dielectric materials. Now, the third one, semiconductor. We can easily understand conductor have 1 valence electron in outer orbit. Insulator has 8. So semiconductor means in the middle. So 8, half of the 8 is 4. So it has 4 valence electrons. So its nature is either to give out all 4 or just receive 4. So that's why they are in the middle. They are neither conductor nor insulator. Example of semiconductor are carbon, germanium, silicon, graphite. Okay, so they use to develop the components like transistors. Okay, so let us see electrical charge. We have already seen, but here the symbol of the charge is Q, which is a quantity, and the unit is coulomb, is according to the name of the scientist Coulomb. So what is coulomb on the charge? So 1 coulomb is equal to 6.25 into 10 to the power 18 electrons if negative charge, or proton if positive charge. And this charge can be stored in a dielectric material. So if like this is known as 1 coulomb. Now another one, we have the basic electrical components or terms. Next, voltage. So what is voltage? Voltage is known as potential difference. So it refers to the difference of charge between 2 points. It's just like water. If the water is in high, they will fall with the force. And in the lower, if there is 2 beaker, one is water is high, one is low, and they are connected. So water will flow from the high water to low until they are balanced. So voltage is same. Okay, potential difference refer to difference of charge between 2 points, and it will always flow from high to low. So Due to that, it facilitate current to flow. The symbol of potential difference is V or sometimes E, electromotive force. It is also known as the electron. So practical unit is volt. So 1 volt means the amount of work required to move 1 coulomb of charge from one point to another point in the circuit. Now the last one and the another one, third one, current. So current is the force to move. Current is the due to the force. Charge is when a charge is forced to move because of potential difference in 2 points of a circuit, then current is produced. So what we can say, current means we can say and the rate at which the charge is moving, okay, and it directly proportional to the voltage difference. So usually current flow in conductors. So in conductors, free electrons can be forced to move from one point to another point, and it can move with a little force, with the little voltage difference also, because they are very free to move electric. The more electrons in motion, the greater the current. Okay, means more potential difference. Okay, so the unit of current is ampere, as we have already mentioned earlier. Okay, and then current actually indicates the intensity of electricity in motion. So it's due to intensity, its symbol is I. Okay, and measured in amperes. So I equals unit movement of charge per unit time. So Q over T. I is the current, Q is the charge in coulomb, and T is the time in second. So ampere, 1 ampere is 1 coulomb per second. As we see, we can see this is the movement of electron flow. And if it is closed, if there is a light, it can bulb. Okay, it's a copper wire. And this is the direction of the movement of charge. Okay, in what we can say in is moving negative to positive, means according to electronic law, okay, or electron theory. Electron theory, because charge always move from negative to positive, but conventionally it is not. Now let us see the resistance. Resistance is the property of a material to resist the flow of charge or current. Okay, so is the opposition of the flow of current is termed as resistance, in other words. And we can see the insulator are highly resistive. Their resistance is very high because they don't allow current to flow. Okay. When the current flow through a cable or wire, we can see it become hot. That's why our light bulb, they give us light and become hot. This is the evidence that there is a resistance and current flowing, so there is a friction. Due to that friction, there is a heat or light. Okay. So conductors have very little resistance, while insulators have large amount of resistance as usual. And now, what is the unit of resistance? Practical unit is ohm. Okay, so ohm is denoted by Greek letter omega. So a resistor, in general, we can say a resistor is an electronic component designed specifically to provide resistance to regulate the current flow in a circuit. Now, what is circuit then? So, electrical circuit is a continuous path made of conductor. Through that, the electron can flow from the generator or from a point and follow the path loop, come back there again. You can see from the battery is a generator. The current is flowing through the bulb. Bulb is giving light and come back to that. Now, can you mark that? Before I showed you that the current flowing from negative to positive. This is according to electron theory. Okay, but here just now I showed you the current flowing from positive to negative. This is the conventional flow, not according to electron theory. Okay? Conventional flow is positive to negative, which we use everyday life, but it's not actually the right one. So these two we can compare. What is the conventional flow? Conventional flow is from positive to negative, whereas according to electron theory, or scientifically true one is from negative to positive as per electron movement. Okay, we can keep in mind. Now, there are two types of circuit. One is closed, one is open. What is closed circuit? Closed circuit, just now we have seen usual circuits where the current can flow from the point and come back to the same point or source. There is a closed loop, closed path. That one is circuit. Okay, this is the closed circuit, and closed circuit, if there is a bulb, it will give the light. Whereas open circuit, there is a broken connection wire, or the circuit is brought down, so it is open. So electricity cannot flow in a loop and come back to the same point again. So the light will not bulb. The light will not give the bulb will not give the light. Okay. Now, since we are discussing about the circuit, we have to know two things. Okay, when there is a current flow in a circuit, how do we know how much current is flowing? And what is the potential difference? Because they are proportional or related to each other. So let us see how we can measure. We can measure the current using a device known as ammeter. Okay, you can see here is the ammeter. This is the battery from positive to negative conventional current flow. And then ammeter has to put in the circuit in series connection. We have to cut the circuit and put the ammeter inside. Okay, we cannot put parallel to measure the current. And we can get the amount of current flowing in the circuit. Whereas to measure the voltage will be the difference, okay, between 2 points. Okay, so since the potential difference between 2 points, we have to connect the voltmeter. We can use voltmeter to measure the voltage, and we have to connect it in parallel of a device for which we want to measure the voltage, okay, or the potential difference. So for the battery, we can measure here. Okay, for this one here is only one resistance. Also, we can get the voltage difference or potential difference for this circuit. Okay. Now, there are two types of current or the voltage. Okay, one is direct current, DC. So usually in a circuit, just like previously, if there is a battery give the direct current. There is no up and down or oscillation in the current. So circuits that are powered by battery source are termed direct current circuits, because the battery maintains the same polarity of output voltage. The plus and minus sides remains constant. Okay, the flow of charge in just one direction. From here in figure we can see Okay, the fixed polarity of the applied voltage, which are characteristics of DC. You can see the voltage level is fixed and only in one direction. There is no oscillations. Steady current or steady voltage. Next, another one, alternating current or AC or voltage. So alternating voltage source provides alternates or reverse in polarity. You can see the sine wave voltage. They are AC voltage. Okay. Our household, all appliances, they use the AC voltage. Okay, it's from the power outlet we use in 60-second cycle. Okay, but usually car battery, okay, the battery we use in toy or remote control or a direct current and DC current and DC voltage. Okay, now comparison of AC and DC. DC is fixed polarity. Here is alternating polarity or reverse polarity. Can be steady, okay, or their fixed magnitude, but varies in magnitude between in reversal polarity or reverse direction. Steady value cannot step up or down by the transformer, but this one, the electrical power used actually for electrical power distribution in household or office, all this. Okay, electrode voltage for tube and transistors, okay, amperes, but this one input output signal for tube and transistor, amperes. Easier to measure, but very difficult to amplify or cannot amplify at all. This one easier to amplify, but measuring is a bit difficult. But heating effect for AC and DC, whatever current or voltage we use is almost the same. Usually for our household, we have to ground the electricity connection and the cable for safety. In the wiring of practical circuits, one side of the voltage source is usually grounded. Okay, so how we can do the grounding? These are three types of grounding can be done. One is connected to the earth, okay, earth ground. Another one through a metal cold water pipe can be also, okay, metal chassis also can be used. Now let us see the electric or electrical components, because just now we have seen the circuit. There are few components like resistor, battery, okay, our source. So they are electric components. So here let us introduce basic electronic or electric components. So all circuit electrical components are fall within two groups. What are those? Either passive or active. What are the passive components or devices? They have no directionality. The components, those consume or store electric current and perform work, a specific work. So usually those are two terminal components. Okay. So for example, resistor, okay, a capacitor, conductor. Okay. Whereas the active, they have directionality. Active components generate, amplify, or supply electricity or current or energy. They are the source, okay, like transformer, I see. So let us see here the active and passive, the comparison. Active components are transistor, integrated circuit, logic gates, operational amplifiers, okay, batteries. Passive are resistor, capacitor, inductor, diodes, as I mentioned. You can see these are the active components, whereas these are the passive. But when we make a circuit or any electronic components or device, we have to combine both active and passive components to form the electronic device or system. Okay. Now, one fundamental or core law for electricity or electrical engineering. Okay, so this is known as Ohm's law. What is Ohm's law? The main idea or the characteristic which based on which Ohm's law is formed is the amount of current in a circuit is always proportional to the applied voltage or the potential difference, okay, V. But in that case, resistance of the circuit can be constant. So what is that? V equals IR. This one V and this I is proportional, R is the constant, so this is equal. And these three we can rearrange to have this. So this one we can say in a triangular form. So V equals IR. Okay, if we want to find the V, if we want to find the I, V divided by R, not multiplication. If we want to find the R, V divided by I. So that's the Ohm's law. So if you know any two factors, V, I, R, among those, we can find the other. Okay, now, based on the voltage or potential difference, there is another power. Okay, another parameters which is or electrical parameter which is power. So the unit of the power is watt. So power is how much work is done over time for a potential difference, and if there is a current or electric flow. So 1 watt of power is equal to the work done in 1 second by 1 volt moving 1 coulomb of charge current. Since 1 coulomb a second is an ampere, means it is current. So we can say the formula of power equals V into I, or V equals, just now we have seen V equals IR, or I equals V over R. We can use those. V equals IR. If we replace V by IR, I square R, or if we replace I by V over R, then it will be V square by R. Okay, so that the power, how we can get the power. So power in watts equals volts into ampere. So 3 forms of power we just discussed. Now let us go for the summary. In summary, I will just show you some very basic or fundamental units and terms. So let us see the SI units. So SI units are length, mass, time, electric current, temperature, luminous intensity, and amount of substance. The unit is like this: meter, kilogram, second. Electric current, which is our main focus for this lesson, is the ampere, and their symbol are ampere is A. But this all I hope you know. And then some important electrical units already we discussed: current, charge, voltage, resistance, and power. This 5 is the main or important electrical parameters or components, okay, or units, and their unit is: current is ampere, charge coulomb, voltage volt, resistance ohm, power watt, and their symbol are this, what we already discussed. W is for watt. Okay. Okay. Now some magnetic units, just for your info in case we need that. Okay. So this the flux intensity, magnetic flux, magnetic force. Okay. Magnetic force and their symbol, like flux intensity, flux density is Tesla. This one used for car mainly. Magnetic flux is Weber, WB. Okay. Reluctance, ampere turns per Weber, so 80 per WB. Okay. Now some of the number when we write there are two conventions how we can write. One is scientific, one is engineering convention to write a number. So, for example, if 47,000, okay, how we can write? We can write into a 4.7 multiplication 10 to the power 7 or 47 10 to the power 6. This is scientific notation. If we write like that, this is engineering. Okay. How do we know, or how we can know that this is the scientific notation? So in scientific convention, okay, the engineering notation is just the number will be as 1, 2 or 3 digit number, then 10 to the power. In scientific notation, okay, the number should be between 1 and 10. Okay, and then 10 to the power power of a 10. So let us see for a number 0.00027, how we can write in scientific. This is 2.7. 2.7 is in between 1 and 10, means it's the digit. Okay, 1 and 10, 2.7, and 10 to the power -5. This is scientific notation. Whereas for engineering notation, 27 multiplication 10 to the power -6. This is the engineering notation. So let us see another example. 0.605. In scientific notation, we can write 6.05. Okay, multiplication 10 to the power -1. This should be within 9, 1 to 9. Okay, cannot be more than that. But in engineering notation, we can write 605 into 10 to the power -3. Okay, now the matrix and the prefix for higher number or the large number, okay, peta, tera, giga, mega, kilo is P, T, G, M, K. We already know that, and they have values. Okay, though you know, just to give a revision, is how we can write the large or the mega value, the prefix. Now let's go for the small one. The small one, there are milli, micro, nano, pico, and femto. Just reverse of the mega or the large values. These are the engineering. These are the smaller value. Okay, so milli is 10 to the power -3, micro, nano, pico, femto 10 to the power -15. Okay, that's all for today class. Thank you.